Hey everyone, welcome back to Protocol Labs Research Seminar Series. Our speaker today is Andreas Stuhlmüller. Andreas is the co-founder of Ought, a nonprofit doing research on using machine learning to support deliberation. Previously, he was a researcher in Noah Goodman's Computation and Cognition Lab at Stanford. And before that, he was a PhD student in the Department of Brain and Cognitive Sciences at MIT, working in Josh Tenenbaum's Computation Cognitive Science group. His talk today is titled Automating Reasoning About the Future, Language Models as Research Tools. Andreas, super happy to have you. I will let you take it from here.
Cool. Thanks, Jonathan. Yeah, that was a good intro. So with that, I can jump right in. The plan for today is I'm going to start talking about a problem that I think we all have and that I'm very familiar with, which is there's increasing research debt. Like research is getting harder to keep track of. There's more research. Things are getting more difficult to organize. And then I'll talk about how we are thinking about solving that problem. I'll explain on a high level, like how do language models work, the tools that we're using, and then how are we using those in Elicit, the product that we're building. So research depth is increasing. What does that mean? There's this chart on the left, which some of you might have seen, which is about how many papers are on archive in the kind of computer science, machine learning, and AI categories. And I feel I feel very familiar with this chart because it like roughly covers the period of time that I was in academia. So I was in academia from like roughly like 2005 to 15, and that is kind of the period of like steepest exponential growth or something like that on that chart. And I remember distinctly in the beginning, so on the right is like the RSS feed of the machine learning and AI categories on archive. And I remember in the beginning, I was definitely able to kind of basically look over all papers that were published in those categories every day. And just check, is there anything that's like relevant to things I care about, or things I care about being things like, I don't know, new inference algorithms for probabilistic programs, for example, or new models of concept learning. And now this is totally impossible. So this is actually from this morning. And this is not, I couldn't even make a screenshot that showed like all the new ones because there are like a few hundred new papers. So there's like some change that has happened, which is making it like much harder to keep track of the work that is being published. And so if I wanted to know what are just the papers that are relevant just on archive and that are kind of important for the work we're doing at Ought, that would take more time than I have. So there's something challenging here. And I guess this is not just a personal failing. I think I'm not like alone in this. Miles, who is famous for like keeping track of all the machine learning papers, said a similar thing. Like if the rate of archive submissions keeps increasing like this, I'll probably have to retire from skimming all the new batches and rely on other people or on bots or newsletters, which makes me sad, but it is a lot right now. And then Chris Ola also phrased it like very nicely. Being a researcher is like standing in the middle of a construction site. There are countless papers screaming for your attention. There's no easy way to filter or summarize them. We think noise is the main way experts experience research depth. So there is a real problem here. And there are a few people who think that this might in fact like point to something systemic where in fact like research is becoming less productive on a per dollar per person basis. So this is a quote from Patrick Collison and Michael Nielsen, who wrote a nice article that among other things says like over the past century, we vastly increased the time and money invested in science, but in scientists' own judgment, we're producing the most important breakthroughs at a near constant rate. On a per dollar or per person basis, this suggests that science is becoming far less efficient. Okay, so that's kind of the problem that we're trying to think about. Like if in fact the quantity of science is making it harder to keep track of what's going on, making it harder to find the relevant ideas and organize them, what can we do about that? The obvious answer is computers read much faster than humans, so we want to somehow leverage computers to solve that problem. And one way, I think it's like worth maybe taking a moment to think about how different computers and humans are. So like think about 100 million characters. If you had a human, so 100 million characters is maybe 500 books or something like that. So if you had a human that would take a full-time employee about 10 months to read them, like maybe 1,500 hours or so. And that would cost about $42,000 if you paid them the average research assistant salary. Whereas if you take computers, and by computers I'm specifically referring to language models here, which I'll talk a lot more about shortly, it takes them minutes. So this is like really like quite a difference. And so then the question is, this is assuming, that computers can do something that is equivalent to the thing that a human would do if they read it, if they read the same content. But under that assumption, that would be a transformative difference. So that would be about a difference of like speed and like say 250 times or so. And if you could in fact like read things 250 times faster, I think that would just substantially transform how science is done, like what types of projects you can even do. I would have no problem following all the archive papers every day. Okay, so what types of computers am I talking about? I'm mostly talking about language models. I think a lot of you have probably been following some of the developments with GPT-3 and other large language models, but I want to explain things in start from the basics and just start by showing like what is a language model. So a language model is just a computation that captures a distribution on completions of text. So suppose I have a text, and here I'm showing like the OpenAI interface. Suppose I have a text like if Protocol Labs were to build an amusement park, then I could ask you, how's that text going to continue? Like, what do you think are likely completions if you read that text on the internet? And you would probably have some idea for what things are more likely or less likely to be completions. You wouldn't know because there are different things that could follow, but you probably would think, some things are more likely. Here, in this case, here's like one completion. It would be called Protocolville. It is a place where everything is possible and everything is safe. Yeah, seems like a plausible thing, you might say. Or like, let's see what another completion could be. IPFS would be the roller coaster. Filecone would be the Ferris wheel. The file system would be the merry-go-round. Those seem like as good completions as you might hope for, or as you might think. So you have this distribution on completions of text, and then what do you do with that? Or actually, before I go into what you do with that, let me first talk a little bit about where that's coming from. Because I guess those were in some sense like surprisingly good completions, right? Like they reflected a lot of underlying knowledge. The model here knows that Protocol Labs has something to do with Filecoin, and I think it even knows something about like what is the spirit of Protocol Labs. So where does it come from? It comes from like web crawl corpus. There is a web crawl corpus called Common Crawl, which has about 1 trillion or so characters. And the way the model is trained is just by walking over like a large part of that corpus, and kind of word by word, or I guess strictly speaking, token by token. Tokens are like somewhat smaller than words and somewhat bigger than characters. And then for each word, you kind of say, okay, I have like my big neural net, which I'm training, and I'm gonna say, make this word more likely, like the word that I'm actually observing. So for example, if I see the sentence Protocol Labs is building that, make that more likely and make every other word less likely. Just do like a small gradient update towards increasing the probability of this single word. And then advance to the next word and do the same thing. So suppose the next word is that, next, then you are going to say, okay, make next more likely, make every other word that I did not in fact observe less likely. And so you just do these like tiny gradient updates word by word to build a model of which types of text are likely to occur in this very large corpus and which are not so likely. All right, so this is, I guess, so far this is just for like text completion. And then the question is, how do you make this useful? I guess you can think like, well, this is already maybe like kind of useful because it's like fun for like generating text that you might use in, let's say, if you're writing a blog post, it could be helpful for brainstorming things. But there's still a gap between text completion and like actually doing useful work, or like doing like useful cognitive tasks. Like most of the tasks you do as part of your research are probably not text completion. So then the question is, how do you go from text completion to other types of tasks? And an important kind of insight in language model research has been that you can convert a lot of tasks to text prediction tasks. So here's a thing I tried a while ago on the left, which is I wanted to make a task that helps me figure out how, if I have a definition of a thing and I can't remember what the thing is called, how can I recreate the name of the thing? So I created a prompt. I created a string that just said, here are examples of the task I want to do. So I wrote like a quotient of two quantities. It's called a ratio. Freely exchangeable or replaceable. It's called fungible. Personal thing that precipitates an event or change. And then I stopped. And so if I showed a human this text, I could ask them, how is this text going to be completed? And they would get that the thing that's going on here is there's some parallel between each of these lines. And therefore, if you were to complete it, you would try to solve the task. And the same thing is true for some language models. So I actually tried this a while ago, maybe, I don't know, a year ago or so at the first time with GPT-2, which is a language model that has about 1.5 billion parameters. And it did not work super well. So the completion it gave me was a firestorm that followed, which is not exactly, it did not actually solve the task. There's something relevant going on here where it's well, this is a noun phrase and it has something to do with precipitation and events and change, but it's not the word I was looking for. And then I tried it again with GPT-3, which is a larger language model, and it said catalyst, which is in fact the word I was looking for. And so there's an important kind of almost transformative shift that has happened between smaller models and larger models, which is you can do this few-shot learning thing with larger models that you couldn't do with smaller models. You can communicate tasks by giving a relatively small number of examples. And we kind of expect this type of trend to continue, models to get better in the same way. So there's some way these models have gotten better in a way that's pretty important. And we expect models to get better like this in the future as they are scaled up more. Because the difference between these two models is almost literally just that one is larger than the other and is trained on more data. There's not really an interesting algorithmic change going on. And so there are results that show that as long as you're not constrained by dataset size or parameters, if you scale up compute, you can kind of predict how much better your model will get. And likewise for the other two parameters. So as long as you have enough compute and as long as your model is big enough, scaling up the data set makes your model predictably better, in a very kind of log scale linear trend. And likewise for parameters. If you have enough compute, if your data set is large enough, just make your model bigger and it will get better. So there's some betting on the future that we can do based on these trends where we can say, okay, we expect these models to get better in the future, get better at text prediction. What can we do with that if they get more like humans on this task? And I guess, going back to the beginning of the talk, our answer is we want to figure out how to use this kind of transformative capability to improve and fix research, and which is the context in which you're building Elicit, the AI research assistant that I'm going to show you. And for Elicit, the basic idea is we can think about what kinds of research tasks can be phrased as text prediction problems. So one type of research task, for example, is going from relatively high-level questions to more specific questions. So I could say, I'm going to give a prompt that says, for each of the questions below, operationalize them. Question, what will the next year look like for protocol? More specific factors, more measurable factors. How many people will join? What will be the most important research topics and so on? I could give a few of those. And then I could store that as a task that I can share with other people and give to them to reuse or compose with other tasks. So that's the basic idea. Create language model tasks and make them shareable, reusable, and composable. And that's kind of what I want to show you. So I'm going to switch to Elicit now. This is what Elicit looks like. There are two parts to Elicit. This is the part where you run language model tasks. And then there's a part where you can create new language model tasks. I'm going to start with the running. And I guess this is my account, which like has a lot of tasks because I've explored a lot of like crazy things. But let's start with maybe one of the more legit tasks. Let's do brainstorm research questions. And so you might start, this is for the early stages of the research process where you're thinking about, you have some high level question, like what is the future of distributed hash tables, for example? And you're trying to make that question more precise or figure out how to explore that question. Then you run it and you will get suggestions from the language model for plausible like other questions that you could ask to make that question more precise. And the important thing that I want to demonstrate here is how you give feedback to the model to make it better. So I ask this question and now I get some suggestions, some of which are good, some of which are like not good, or some of which are more like the things that I want to think about here, and some of which are less. And so I'm going to select the ones that I like more. What are the common indexing and query schemes I like? Who employs distributed hash tables and why I like? What research groups have the most publications on distributed hash tables? And then all the other ones I can throw away by clicking clear and start. And then I can say show more like start. And the ones that I selected here get added to the prompt. So they get added, shown to the language model. And then the language model will know that other kind of completions like the ones I added are to be preferred. So here's like what new papers add to our understanding of distributed hash tables. How do query loads changes in indexing schemes vary? How does cluster use change over time? And it can like I think one of the interesting things of language models is that it has kind of this infinite generativity. Like, I can just keep clicking show more like start forever if I like. And then some of the suggestions are not going to be that interesting. Like, is a hash table a hash table? But I can really support like my brainstorming process by kind of going like, there's never a point where the model is like, I don't have anything to say. So that is one example of a task. And I actually thought for this audience, it might be interesting to create a new task together. And we asked some people at Protocol for what types of tasks might be interesting to them. And Carola said, here's one example, like if you submit papers on these topics to these conferences, what are some other journals or conferences that we might not have considered? Which I think is like an interesting task to consider making. So the task in this case would be suggest a venue for a research topic. And then the way I usually start by making tasks is, so this UX is like a little bit complicated, but the important part is the way you usually start is by saying, what's an example that I want it to work well for? So I start by creating my test set. And so, for example, my test set could be I want crowdsourcing as an example topic for which I might want reasonable suggestions. So I add crowdsourcing, I save it, and you can see that before I've trained the model, these are really like not very good suggestions. Like these are not venues. These are this is just the type of text that the model expects to see on the internet after it sees the word crowdsourcing. And then I can add more information to the task. So I'm going to add, I'm going to say there's a specific input type here, which is like a research topic, and a specific output type, which is relevant venues. And then this has already like changed the predictions a little bit. So now some of these are like somewhat closer to like researchy things, like to venues, but these are still not good suggestions. And then the two things that really make a difference are one saying, giving instructions to the model. So saying, for each of the research topics below, I'll suggest appropriate conferences and venue and journals to publish in.
A quick question. For output type, would it understand if you instead of venues said conferences or journals?
Yeah, that would make a difference. So I guess.
I guess mostly, if I'm wondering if the language model has a method of, or is capable of parsing the or as like a logical operator between two different types, or if the type is best represented as one word.
No,
one idea.
Okay, conferences or journal. I think we can just go with that. I think that makes as much sense as saying venues, and it'll work just as well. Maybe it'll work even better. Sometimes being more explicit is better than being being too concise. So let's just go with that and see what happens. Okay, so I think this already, this is like slightly closer to reasonable, but as far as I can tell, still not super reasonable. And then the thing that really makes a difference is adding examples. So I'm going to add like some examples of research topics and conferences that I know about. So let's say machine learning. In machine learning, there is a conference on machine learning, ICML. And then there is NeurIPS. And then there's the international, there's ICHCAI.
So here it's kind of like thinking about if you had an actual research assistant and you wanted them to help you with a task, you would probably send them a long email that describes instructions for what the task is and give examples, like maybe a spreadsheet of a couple of rows filled in. So it's like a more structured version of that, where you imagine Elicit is your research assistant.
Okay. So after the first example, you can see this has made a big difference. Now these look a lot more, both in the format and in suggestion, these look a lot more like actual conferences. And in fact, like I think HCOMP is probably the best conference for this type of thing. I'll add one more example just to make it a little bit more robust. So in cognitive science, maybe you'd want to publish at the CogSci conference, and then in the Trends in Cognitive Science journal. So usually you'd give maybe between 5 and 15 examples. Here, I'll just give 2 examples. And I think even with 2 examples, it'll work reasonably well. I think both like HComp and Kai are probably the things I was looking for here. And now that I've defined this task is available to anyone I share it with. So I guess if I go back to the homepage, we now have a new task, suggest a venue for a research topic, and we can run it on whatever we like in the same way that I ran the Brainstorm task earlier. And I think it's interesting often to generate tasks where, or to try tasks in cases where you're not sure what the answer would be. For example, I might be like, where should I publish about compositional data structures? And I'm actually not sure where I should publish about compositional data structures. And so I run this, and then I check the ideas, and it's like, maybe you should publish at the ICFP, which seems kind of reasonable. Theory of computing. I think functional programming is maybe the direction I want to most go in. So I remove everything else, say show more like start. Journal of functional programming could make sense. So you have this like iterative process in the same way that, we had the iterative process earlier for the predefined task, where I can look at here, what are some ideas for transactions and algorithms for places to publish at. So that's a generation task. You might have seen, or maybe you didn't, but when I created the task, there was a field where I could select different types of task, and only one of the tasks was generation. We also have search tasks and other types of tasks. And I think I want to now look at classification, which is the type of task we've most worked on recently. And there, Yanis gave us another nice example, which is of a task that we can consider. Like they said, there are many, many papers that refer to IPFS. A very big portion of them just refer to the decentralized storage system, do not investigate or extend the capabilities. Then there are others that work on kind of proposing parallel extensions, performance, enhancements, etc. In general, we want to distinguish kind of between different types of papers that refer to IPFS. And I think the specific like distinction here is maybe like a thing I can't like totally build in like this talk, but we can consider like this type of task and see how far we can go. And to do that, I started by just downloading like all the papers that mention IPFS from Google Scholar. There are really a lot. I guess there are like about 4,000 or so that I could find. I was like, wow. And now I understand why you guys feel like it's hard to keep track of what's going on. So well, let me pop up a second here. So the basic the basic problem here is like there are really a lot of tasks that have the format. I have a large spreadsheet and I want to do stuff with it. And when we talk to researchers, often they're like, the types of tasks I give to research assistants have the form, here's a spreadsheet, and I want you to go through the rows and like either like classify each of these as like what type of paper is it, or what type of person is it, or what type of organization is this. Here are a few examples of how to do it. And now you go and like classify the remaining thousands of rows and come back to me in a couple of days when you're done. And that is, in some sense, that is like just a human few-shot learning task, because you're basically just demonstrating to the person, here's some examples, now go and do the same thing for all the others. And the task is often not that hard, because like often it's literally just a thing where you need to like look at the text and make some relatively simple judgment about the text. Especially if it is a task that you can in fact give to a research assistant who doesn't have like deep background knowledge. So I wanted to think about this for this like IPFS like kind of papers task, where you're trying to understand if I have a long list of papers, how do those like fall into different categories, or how can I kind of start organizing them? And one way, I guess, one way we might start organizing them is by thinking about, well, some of these are going to be about uses of IPFS in the context of the Internet of Things, and other ones are like not going to be in that context. And maybe we care about finding the ones that are that have this particular use. Or I guess you could imagine a more complicated classification scheme, but I think I'll just go with this one, since like I don't know the details of which classification scheme is going to be most interesting to you. So I'll just say, I look through these rows and I'll say this one. So I added this user tag column here, and I'll say this one is about the Internet of Things. I'll say IoT storage. And then for others, like this one, I'll just say not IoT storage. This one, I'm not sure. This one also, so not IoT storage. So I add a few examples, and then I go back to elicit. And the task we have here is called AutoTag as CSV beta. And I can just say, I want to select a Google Sheet and have elicit help me do this classification task. So IPFS. Select. Now I've selected the sheet, and I can click auto tag, and it's going to run it and pretend to be my research assistant and try to help me fill in those columns. This is going to take a little bit, because it has to run the model for each of the 100 rows. And it's going to both show me the result in the app here, and it's also going to add a new sheet to the spreadsheet itself, so that I can continue editing there. And then if I want to rerun it. So it says your Google spreadsheet has been auto-tagged. And in the app, I can see for the ones that I like didn't tag, it tells me here's my predicted tag, and here's how confident I am. And then I can go back. So here's a new sheet that has been added. And now everything has tags, and everything has an associated confidence. Usually I sort first by confidence and then by tag. And then let's just look at the ones that it tagged IoT storage. Okay. I might have given too few examples. I was a little bit ambitious here by trying to make it work with fewer examples. But you can see here's like IoT trust management is one that found here. Okay, I think I would recommend probably giving more than like 2 examples if you do this classification. I will.
Question in the chat as to whether this is still on GPT-3.
Yeah, this is running GPT-3, and it's making one call for each of the rows. How do
you get the confidence levels through that?
The confidence levels are we check for different types of words. So there's or different types of strings. There's the string IoT storage, and then there's just the string not IoT storage. And those just have different relative probabilities, and those are the confidences that we report. Those are actually like surprisingly well calibrated usually, at least if you give more than the 2 examples that I just gave.
So they're post hoc from the GPT-3 outputs. You're taking the GPT-3 outputs and then computing something off of that?
No, you get, in addition to the outputs, you do get the probabilities. So that's just a thing.
Oh, the probabilities. Okay,
you can
got it.
Create the model for. Okay, sorry, go ahead.
Oh, I was just going to say here, what we found useful is obviously when it classifies things really well, that's useful. But it's also just useful to have a very cheap third perspective, even if you do have human labelers. So some of the organizations we've worked with had research assistants or their team tag things. We ran it. And at first we were like, oh, we didn't match the human labels as closely as we thought. They went back and looked at where we disagreed and thought, okay, maybe these classifications were a little unclear. And then the other thing researchers are really excited about here is the ability to iterate through classification schemes very quickly. So we've heard like lots of stories of researchers who've had to spend like months tagging large data sets, or, you delegate it to a research assistant team. They're going to spend a ton of time on it and get it back. You can't really do that many times, right? So if you change your classification scheme, it's very it's very expensive to like rerun it. But here you can kind of be a little bit like lazy or iterative with your scheme. So like first try not IoT storage versus IoT storage, then review some of the examples and say, actually it's, these 2 groups are not quite it. I think I need a third group, then apply that. And so that's really where we want researchers to be thinking, right? Like what are the high level categories more so than what is this specific example? That's the one we want to be able to delegate to something like GPT-3 or Elicit. And then we want researchers to think at the level of how do I break this space down? That's where their reasoning and their expertise is best applied.
Yeah, I agree. I guess, as you can see in this talk, I really plan to demonstrate the iterative nature of this to you by seeing now, I reran it and now it is, so now the most likely thing for IoT storage is like this connected vehicles mobility data storage thing, which is a much better suggestion than the one before. Like a lot of these are already more reasonable. So this is just like how I think it makes sense to apply this, to be like, well, I'm going to do the minimal amount of work that I think is required to do reasonable classifications. I run it, I check a bunch of examples, I fix the ones that I think are wrong, and then I rerun it. And that's a process that like really wouldn't work that well with a human research assistant, or they would get very frustrated with you if you did that with them. It's nice that you can do that here. I wanted to very briefly demonstrate one other type of task, which is a search task, in part because because I had like exported all these papers, I was like, maybe I should also just make a search task for it that searches all these the IPFS papers by like literally just using the titles and snippets, not actually using the contents, as an example of how easy it is to make semantic search tasks. So I ended up using that a bunch for my own work, just being like, oh, here's like the bibliography of like 5,000 or so papers that I've gathered over the years. But it would be nice if I could easily do semantic search over them to find papers. And so I made a similar thing for these IPFS papers, where you can ask, like, you can search. So for example, I don't know, market mechanisms, and then it'll just use a language model search endpoint, do like a sentence embedding type of thing, and show you the most relevant ones in this case. So here's like protocol for organization of a decentralized autonomous agents network in factories using market mechanisms, new market model with social and commercial tiers, implications of distributed ledgers, markets, communication networks, and algorithmic reality, and so on. So that's another type of task that is pretty easy to experiment with, because you literally just upload, a big text file, and then you have a semantic search task that you can play with. There's one other example that you might like, which is searching forecasting questions. So that's another search task that we regularly update. So this just searches all the online prediction platforms like Good Judgment, Open, Metaculus, and so on. And so if you're interested in like what are the forecasting questions that are most relevant to a particular type of topic, this is a good way of finding them, of doing like semantic search over them. So here, suppose I want to know what types of forecasting questions relate to cryptocurrency are there, then I can just run this and be like, okay, will 3-ton cryptocurrency project be successful? Total market cap of all cryptocurrencies. And then if I'm interested in any of these, I can just click on them and check what is the crowd prediction for these. Will Bitcoin lose its position as the dominant cryptocurrency, and so on. All right, so I've shown you like the different types of tasks you can run on Elicit, and I want to briefly zoom out to what we see as the bigger picture here. So all the tasks I've shown you are like relatively atomic tasks, and we see them as part of a project of systematizing the research process, where we try to understand when you do research, what are the kind of the steps you're going through, and which of those steps can be automated or not automated, or like there's like an incremental automation story where some of the steps can be automated soon, some of the steps can be automated in the long run, some of the steps maybe can't be automated for an extremely long time. And so one thing we want to have started doing and want to do more is just watching researchers, observing them, seeing like here, what in detail, what do they do? And here's this slide is one verification of that. So that comes from us watching people at think tanks and understanding their work better. And there often the work is, you start with a relatively high level question, like what's the future of cryptocurrency? You're trying to understand what is the landscape, like what are the relevant concepts, or what concepts, what are the relevant other papers that people have written. You generate initial hypotheses for how things are going. You try to find relevant data. You write up the results. And then the way we see Elicit fitting into this is by saying, okay, each of these steps can be supported by different types of tasks on Elicit. And we can kind of try to cover the whole spectrum of tasks over time, starting with the things that are easier to automate. And some of the things I've shown you you can try to fit into this framework. So there's brainstorming research questions, which we started out with, which is like a thing you probably mostly want to use at the beginning of the research process. Then there's like understanding the landscape. You might want to do things like searching through IPFS related papers or searching through forecasting questions. Then there's like a data analysis step in some projects where you could use the auto tag spreadsheet functionality. And then for writing up the results or publishing, you might want to think about, well, where could I publish this? Like the generating journals and conferences task that we made. I think this is still this obviously still covers the process extremely sparsely, but you can already see how over time you might expand to cover more and more of the process and chain together these atomic tasks into larger research workflows. So to recap, the overall vision is we want to make research processes explicit in the way that, like I just described to you. Once they're explicit, they can be improved through feedback. Like even ignoring the automation story, it's nice to be able to say, here are the subtasks that I run when I do research. Can you give me feedback on this? Or like, here are sequences of tasks that I run. Can you give me feedback on this? Or can you tell me the ways in which these tasks could be run better or could be decomposed into alternatives? Once research processes are explicit, we can incrementally think about making them automatic using language models, and we can make it easier to share them with coworkers and other teams. So we made the suggest conferences and journals task in like 5 minutes, and now it's a thing that we can share with other people, which I think is pretty cool. All right. You can sign up for Elicit at elicit.org. Happy to take questions.
So one question that I had from early on about talking about trying to reduce the academic debt from the massive explosion number of papers, I could imagine eventually this becoming an arms race where you have computers reading the papers and like highlighting them, but you also have computers writing the papers, and much in the same way as you see like advertisements that are generated to try to hijack like human subconscious. I would expect you'll have paper generating systems that are trying to hijack the paper synthesizing systems. And I guess most of the problems are solved by the fact that like you could probably still filter by things that are peer reviewed. The capacity to peer review scales with the number of scientists roughly. And so even though that will be exponential, that'll still be like somewhat increasing. But I was curious if you see issues or like potential concerns that might show up in the long term.
Yeah, I guess I think of it less as issues and more as like an interesting question, which is like in the long term, what is the level of abstraction that people operate on? Like suppose you're living in this world where like most writing is generated by machines and most writing is consumed by machines. You could imagine that maybe like people just operate on like outlines or like do tasks that are somewhat different from the low-level tasks that people do right now. We were thinking about this in the context of, I think there's a version of this that is actually like kind of pretty relevant in the near term, which is we were thinking about an illicit task which turns free-form text into structured outlines, because none of us at Odd really like reading free-form text, and we just like skimming structured outlines. And so suppose we make that task, and then we mostly read things in terms of like structured outlines. And then we probably also want to just do most writing in terms of structured outlines and just generate free-form text in cases we need to generate a blog article because other people like reading free-form text. Now you have like this translation layer where we just interface with kind of structured outlines. And you can imagine a world where everyone else has a similar translation layer and no one really cares about the free-form like detailed structured text, and everyone just operates on these compressed representations. And maybe that's fine, but I think there is a question about what exactly it looks like.
I guess to some extent, that's how like most I would assume that's how almost all non-lawyers deal with the legal system. It's this like Noninscrutable framework that you just interact with abstractions of. And I imagine you could come up with other examples. I think that there's probably some like weird second order effects that show up where like people don't even try to read, like some people don't even try to read legal documents because they don't feel like they need to, or they don't feel like they could. And I could imagine that being particularly interesting for science, where like, I think that there's this huge gulf between like pop sci explanations of phenomena and then like the rigorous scientific explanations. And if the tools don't close that gap, but instead make it more, make the distinction less obvious to an uninformed person, I could see that being a very interesting societal thing. But I don't think that that's necessarily the direction you would have to go.
Yeah, I think I guess pop science is kind of like a translation layer to the, I don't know, least common denominator or something. And so you could imagine translations for you that are of the same length as pop science explanations, but are just phrased in terms of concepts that you already understand better and that therefore can communicate much more to you than the pop science explanation could. And I think they're pretty excited about that sort of like personalized like future, or like personalized summarization, I think is a really exciting direction.
Yeah, I loved the GPT-3 explain it like I'm 5 demo, and I imagined it being like, explain this to me like I'm a physicist. And like sending it legal things or finance things or like biological things and having it explain it using like very densely laden terms and concepts that I'm familiar with.
Yeah, I just want to explain like I'm Andreas.
Other questions?
Go ahead. Oh, I was just going to say, beyond classification and outlining and summarization, I'm curious if there are like any other nascent applications in the ingesting part of the process. Say if you have 500 new archive papers, are there any other things you were thinking about doing with them?
Yeah, I mean, there are really a lot of things. So one of them is like this action I'll just demonstrate briefly that we call search factors, which is we like, so for a lot of papers, the main takeaways you can get by just looking at the figures and their captions. You don't actually need to read the text. And so suppose you have 500 papers and they're like on a particular topic, like they're about, I don't know, AI and employment. And now you have a question that you're trying to answer, like what's like how many CS like PhD graduates are there? Then a thing we've done is we used language models like supported by human work to extract the captions from these papers and made this search action, which is just for searching through the captions. I think that is often a more useful thing to search through than the kind of just the paper titles and abstracts, because you're more directly searching through the data. And
that's super compelling. Yeah.
So let's try this one. And so here, so I'm searching through. This is from like 20 think tanks. So here I'm searching through captions, and then it tells me here's data on where CS PhD grads from the US originally from, what percentage of international CS PhD students stay in the US, number of CS grads. Okay, this is maybe like the type of thing I want. And then I can just be like, let me copy the caption. Let me go to the publication and search for the caption. And then I'm like, and now I have like data, and I didn't need to read like a ton of papers. I just can see that, in fact, the CS grads from from US citizen CS grads kind of stayed more or less constant, but foreign students who study in the US like really went up a lot in this time range. So that like, I think if you expanded this to a broader range of publications, I think that itself could be a killer application.
I think just a quick follow-up. This is all like semantic search, and semantic search models, of course, there's a lot of them. And so I'm curious what GPT-3 affords here. Is it just that it has this generality where you can use elicit to do all these specialized tasks very quickly, or is there something more?
So I guess to elaborate on the technical aspects of it, the way we do semantic search is through a two-stage process where first we do like a more basic sentence embedding to narrow down like thousands or tens of thousands results to maybe the top 100 or so. And then we use GPT-3 to re-rank the top 100. And I think that re-ranking step does add something. I think like GPT-3 does have a better like understanding of what's going on. So that's probably the main benefit, is that you want to think about semantic search in terms of kind of a sort of like pipeline where you do like a very coarse thing at the level where you consider the most results, and then incrementally do more expensive things as you narrow down the results to the most relevant ones.
I see. Yeah.
I had a question that was related to a comment I left in the chat at the beginning. Have you considered applying any of this to pattern searching? Because it seems like So from an impact perspective, obviously, I mean, the patent system has the potential to both foster and greatly hinder innovation, but also as a business, I mean, like this is the like automated discovery similarity classification is the holy grail for every patent office around the world, and for any firm that's involved in patent law matters. So it seems like this could be a huge business or application.
Yeah, I think that did come up. Jangwan, do you remember the context in which patents came up for?
Yeah, I mean, so we work with a lot of tech think tanks, and they are certainly interested in classifying patents, searching through them and parsing them. And so we're happy to do that. We just want that's like a very broad space to enter into. I think, like you said, you could build an entire business just focused on patents. So we probably want our participation in that to be much more user driven. So if there's a specific user who wants to do this specific thing with the patents database, you know, we'll solve that project first and then see how that generalizes and potentially make that more broadly available. We've had a couple of requests for this already, but I think once we see a more like well scoped project, we can start entering into that. But like, yeah, if you have a specific use case, then we're happy to explore that with you. That's actually, I think, one of the biggest challenges with illicit is like there's so much to apply to. Like I think in the chat, someone also suggested the legal domain. That's like very, very tempting, but I think it's important for us to stay focused on the research community. And someone probably will build like an amazing language model application for processing legal documents and precedents. Maybe that's us in the future, but I think right now we need to stay committed to our core user group, which are these researchers, and then, you know, incorporate these applications only if they are researcher led.
I think a lot of us are really interested in knowledge graphs. And I was wondering if you had any thoughts about how to sort of integrate knowledge graphs into what you're doing, sort of either using them for few-shot learning in place of sort of individual training examples, or like using GPT-3 or some version of what you're doing to assemble knowledge graphs.
Yeah, I think both like GPT-3 and similar models are definitely like very appealing for assembling knowledge graphs. And there are maybe two versions of doing that. One is taking the implicit knowledge that is in the language model and making it explicit. So for example, a thing I did is just trying to extract networks of causes and effects from the model. So you can ask the model, if it rains then, and then, you know, just complete the text, and then maybe it'll be like the grass is wet, you'll need an umbrella, whatever. And then, so you could build a causal model just by trying to extract the knowledge that is already in the model by doing systematic querying. And so that's one direction. And then the other direction is turning documents into more structured representations. I think it's like this is the caption extraction example I mentioned. Actually, like one of the main reasons we did it is just as a kind of trial run for more interesting extractions. So thinking about, if you have a research paper, can we extract what are the proposed next research steps, or what are the proposed like obstacles, and like turning free-form data into sort of structured representations, I think is just a thing that these models are like relatively good at. So it makes a lot of sense to apply them there.
What shape is your knowledge graph in currently? Or how do you keep track of your information?
Yeah, I mean, some of us use Rome or versions of Zettelkasten, and we have a few research projects on building knowledge graphs.
Yeah, we've talked to Rome and Connor like quite a bit, and haven't quite know there's some opportunity there, but haven't quite scoped it out yet. Some of the things that different Rome users have asked us for are like suggesting tags. So I think now there's like Rome debt also happening, where it's like people just like throw a bunch of stuff into Rome and they're like, oh, I'll tag this eventually, and then they just don't. And so if we could like more thoughtfully suggest tags, that might be helpful. I think Rome's tags are like reasonably useful, but I think search in Rome is still not perfect. So people have just wanted like simpler search over their notes. Yeah, those are some of the ideas we've already thought through. And then it's just been a little bit unclear whether like we should build that or Rome should build that. I think it was tricky. I talked to one user to create like a search over the Rome export, which is like in Markdown, and it wasn't like quite rich enough to make it easy. But yeah, maybe if you have something richer, we can take a look at that and see if it makes sense to integrate into Elicit.
Thanks, everyone. And thanks, Andreas. That was a really great talk. Our next talk is next week, May 4th at 1700 UTC from Sarah Azuvi, who is a consensus researcher at Protocol Labs. Her talk will be on tools for game theoretic models of security for cryptocurrencies. If you're not currently on our mailing list, please sign up in the footer at research.protocol.ai. You can specify what types of emails you want to receive. We send out monthly talk previews, quarterly newsletters, and information on research funding opportunities. If you do have a speaker or topic for future research talk, please email us at research@protocol.ai. We'd love to take those suggestions. Thanks for joining, everyone. We'll see you next time.